Hello everybody, and thanks for watching my talk. My name is Tobias Drey, I'm from Ulm University, and I want to present you VR sketching, exploring the design space of pen and tablet interaction for 3D sketching in virtual reality. First of all, I want to jump right into it and show you our system. Here you can see an in-game capture, and on the bottom left you see the person who is using the system. VRSketchIn is a VR sketching application, and it uses 6 degrees of freedom track pen and 6 degrees of freedom track tablet as input devices. This combines unconstrained 3D mid-air sketching with constrained 2D surface-based sketching. To explore what possibilities arise from this combination of 2D and 3D input, we present a set of design dimensions and span the resulting design space for the sketching interaction metaphors. But why did we do all this? Sketching is an important part of the design process. It enhances visual thinking. Sketching in VR improves the understanding of 3D volumes, but it's challenging, as in mid-air there are no constraints, and the controllers are not made for sketching. They are optimized for gaming. Here you can see Glenn Keane. He's a very famous designer from Disney, and he created popular movie characters like Aladdin or Ariel. In this video you see how he's using a VR sketching software which is focusing on the unconstrained 3D mid-air drawing part. This has all the previously explained challenges. When you look how he's working nowadays, then you see that he is still using pen and paper. And he puts them on his desk, which gives him all the benefits from surface-supported drawing. We want to merge the best of both worlds and create a system for interchangeable and unobtrusive 2D and 3D sketching. Therefore, we created VRSketchIn, which provides unconstrained 3D mid-air sketching as well as constrained 2D surface-based sketching. Before I start to show you VR sketching, I want to discuss about related work and show you what inspired our system. The first paper I want to present you is Symbiosis Sketch. It was presented on CHI2020. Here you can see that it is possible to immersively draw in mid-air and also have the link to life-sized object as it is an augmented reality system. It is furthermore possible to define drawing surfaces in mid-air. They can be curved or flat. They are then linked to a tablet, and when you draw on this tablet you can see how this is also mapped to the drawing surface in mid-air. The system inspired our design space and it can be grouped by it. The next system I want to show you is Tablet in VR. It was presented at CHI2019. It combines mid-air gesture input with touch input on a tablet. With these interaction metaphors, it's possible to create and manipulate primitives like this cube here in the video in virtual reality. This system also inspired our design space and it can be grouped by it. Before I want to show you everything in detail, I want to give you a brief overview about our contributions. First is the definition of a design space, which is based on expert interviews, 10 in total, as well as the presentation of interaction metaphors which arise from this combination of 2D and 3D pen and tablet based input in virtual reality. The second contribution is the implementation of VRSketchIn. This combines the 3D mid-air sketching interaction metaphors with the 2D surface-based interaction metaphors on the tablet. And the third contribution are first insights regarding the usage of VRSketchIn, which are based on a 2-hour-long usability walkthrough with 6 participants. Now let's show you our design space. We created this design space to systematically explore the combination of 2D and 3D pen and tablet based input. We conducted a morphological analysis with 5 iterations to create the final design space. We see 3 use cases for this design space. The first use case is the ideation of new interaction metaphors. The second use case is to investigate interaction metaphor gaps in existing applications. And the third is to categorize prior art and identify underexplored parts. We did all these 3 steps during our creation of VRSketching, and we present a populated version of our design space in our paper. On this slide here, now you see an overview of our design space. This has 2 dimensions, and the first dimension is based on the used hardware, which is called input devices. The second dimension is based on the expert interviews and related work. It is called sketching operations. You get in our paper a detailed overview about the different interaction metaphors we group inside this design space. Now I want to show you the system VRSketchIn. It's an artifact contribution according to Woodbrook et al. 2016. We selected the implemented interaction metaphors based on our design space, and we made sure that all parts are covered with VRSketchIn. As hardware, we used an HTC Vive Pro, a Wacom Intuos Draw tablet, and used OptiTrack for the tracking, which allowed us to attach very lightweight trackers to our devices. To create our customized pen, we used a Logitech presenter to have button input in 3D midair, disassembled it and put it into a custom 3D printed case, and also added the Wacom pen to this custom 3D printed case to seamlessly switch with this pen between 2D surface-based sketching as well as 3D midair sketching. The most direct way to sketch in an immersive environment is 3D midair sketching. Just put your pen at a position and press the button to create a stroke, as you can see it here in the video. The drawback is that you have to manage 6 degrees of freedom at the same time, and there are no constraints. That's the reason why we implemented several interaction metaphors to support sketching. Sketching with reduced degrees of freedom provides higher precision. That's possible with drawing surfaces as shown here. Just place them in space by the tablet position and orientation, and it's also possible to scale and change the distance of them. Everything that is sliced by the surface is shown as preview on the tablet. Sketching on the tablet creates primitives in space at the position of the drawing surface. As example, you can see here how this is done to create the sea around the ship. Of course, it's possible to switch back to previously created surfaces. With World in Miniature, it's possible to interact with the whole space in the vicinity of the user. That's possible because it's attached to the tablet. This also allows easy perspective taking, because you can just rotate the tablet. When you interact with World in Miniature, then it freezes its current position, which allows a more stable and precise interaction. All interaction metaphors that are possible in the real space are possible in World in Miniature as well. Portals and extrusion are further interaction metaphors. Extrusion is a very common feature because it allows to easily create solid objects out of strokes. Portals are used like virtual cameras for perspective taking. They can be created like drawing surfaces, and the camera view is then attached to the tablet. To evaluate our system, we conducted a usability walkthrough. We recruited 6 participants through convenience sampling. Sessions were between 90 to 150 minutes long. You can see the sessions and what the users sketched in this video. Our usability walkthrough had 3 phases. The first was an introduction and training phase, where everything was explained to our participants. This was followed by a free sketching phase, where they had to sketch a beach house on an island in the sea. And that was followed by an interview and a questionnaire. We conducted a thematic analysis and grouped similar answers. In this video, you can see one example from our participants. And that's another example. I want to show you our results in a brief overview. For 3D mid-air sketching, we saw that's a powerful tool. Precision is lower, of course, but it's sufficient for sketching most of the time. Drawing surfaces were used for inorganic parts, like straight lines or walls most of the time. World in miniature is good for perspective taking. Interaction is also possible, and that's useful to interact with distant areas, but precision is lower. We conclude there are distinct use cases for 3D unconstrained mid-air drawing as well as 2D surface-supported constrained drawing. We observed that they were used disjoint most of the time. We think that's an interesting observation, and it should be investigated further if this is due to the interaction overhead to switch between interaction metaphors, or if there is any more fundamental reason behind this observation. I want to conclude my talk and show you this beautiful scene of 3 islands created by our participants and the ship in the middle, which was created by one author. Thanks for watching my talk. Do not hesitate to write me questions, and of course, enjoy sketching.